Alright, so we got a quiz coming up. I've got the whole review page in front of me. My suggestion would be for you to sit down, take this quiz, treat it like it's a quiz, see how you do, and then you can watch the video and sort of grade it. So if you want, hit pause and do that. If you want to watch me go through all the problems, I'm going to go ahead and do that right now. So the first section here, we're simplifying exponential expressions. So remember, when you've got a power to a power, this is on the outside of parentheses, we're going to need to multiply all of these exponents by 2. And it looks kind of like the distributive property, but it's not really the distributive property. We're going to do 1/2 times 2, which is 1, 2 times 2, which is 4, and then z to the 10th. Over here, we don't really have anything. It's just be x to the 3/2, y to the 1/2. So now what we're going to do is we're going to multiply all of these. And when you're multiplying, the rule is that you add the exponents. So let's look at our x's. We have x to the first and x to the 3/2. So what's 1 plus 3/2? Well, remember when you get a fraction, you need a common denominator. So 1 would be 2 over 2, 2 whole. So this would be 5/2. So we have x to the 5/2. Y to the 4 and a half, which you can probably just do 4 and a half and convert it, or you can do 4 whole, which is 8/2 plus 1/2, so you can get y to the 9/2. And then you have, looks like just z to the 10th. So x to the 5/2, y to the 9/2, z to the 10th. That's our first one. So let's try another one. We're going to pretty much play the same game. So we got a power to a power. We're going to do x to the 3/2 times 2. When you're multiplying, you just multiply across, so that's 6 over 2, so this will be x cubed. Y to the 4th, and then we have x to the 1/2 y. So again, we're going to do 3 plus 1/2. 3 is 6/2, so that's 6 plus 1 is 7/2. And then y to the 4th times y is y to the 5th. Well, when they're fractions, you're going to do the same thing, but when you have the denominator here, we can actually simplify that. Let's do the top first. We got x to the 8th, y to the 8th. Now in the bottom, you have to the 1/2 power. Remember, that's the square root. So if you can remember that the square root of 64 is 8 and the square root of x squared is x, then you can make this problem quite a bit easier. Now you have 8 x's in the top and you have 1 x in the bottom, so that means you could cross out the 1 in the bottom and then you would just be left with 7 in the top. So x to the 7th, y to the 8th over 8. One more. 1/2 times 2 is 1 whole. 2 times 2 is 4, so that's in the top. And now this is the cube root of 27x to the 5th. So 27 is a perfect cube. That's 3. And then let's talk about the cube root of x to the 5th. X, 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 x. The cube root, I'm looking for sets of 3. So for 3, every 3 underneath, 1 can come out. So that means I'll have a 3x that makes it out. But I still have, you know what? Honestly, the best way to do this would just be to think about it. I'm going to change the way I'm doing this because this will be better. If you're using the same rules, it's 27 to the 1/3 times x to the 5/3. We're using the exponent rules. 27 to the 1/3 is 3, so this is 3x to the 5/3. I'll come back to the radical stuff. That's the best answer for this one. Whoa, that didn't work. That's the best answer for this one, though, honestly. That's probably the best way to do it. We'll talk about how to simplify the radicals in the next section. So we have xy to the 4th over 3x to the 5/3. But we got to finish that one. Okay, let me finish this. This is 3/3. Okay, so if there's 3/3 in the top and there's 5/3 in the bottom, you would subtract 5 minus 3 to get x to the 2/3. All right, this kind of is a little trickier than I thought. Y to the 4th over. Since you have x's in the top and the bottom, you do need to use your rules to simplify. So 5/3 minus 3/3 is 2/3. So y to the 4th over 3x to the 2/3 is your best answer. Okay, a little bit more than I thought. Let's do the radicals now. So square root. All these problems I'm going to treat the same. I'm going to make a factor tree for 128. I'll show you how to do it by hand, but normally I'm going to do it in my head. 128 is 2 times 64, which is 2 times 32, which is 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. We're making a prime factorization of 128, which is 1, 2, 3, 4, 5, 6, 7 2's. 2 times 2 times 2 times 2 times 2 times 2 times 2. 7 2's. If you're taking the square root, you're looking for pairs of 2's. Because 2 times 2 is 4, the square root of 4 is 2, so 1 makes it out. Another makes it out. Another makes it out. What's trapped? That 2. Now we got to still do the x's. So the x's, well, that's not going to have any friends. He's not going to make it out. But if you have y, 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 you can say a y will make it out. X isn't going to make it out. So what's left underneath? We have a 2, an x, and a y. So this will simplify to 2 times 2 times 2, which is 8y radical 2xy. 8y radical 2xy. When you do cube roots, we're going to play the same game. 250. So I'm going to do a factor tree in my head. That's 2 times 125, which is 5 times 5 times 5. And then x, 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 y. That's what x to the 7th means. For cube root, you're looking for sets of 3. So I'm going to circle all the sets of 3 that I have. And that means for every 3 underneath, 1 makes it out. So if you already have a 5 on the outside and you bring another one out, now you have 25. Bring an x out, bring another x out, that's x squared. That's all that's making it out of this thing, but we still have the third root of 2xy. That's all that's left underneath. Number 7. 4 times the third root of. 40 is 5 times 8, which is 2 times 2 times 2. And then x, 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 y, y. You probably don't need to break it down as you get better at this, but I'm going to do it that way just to show you. Third root, so looking for sets of 3. Set of 3. I'll do it in a different color, make it easy. Set of 3, set of 3. That's it. So 2x is going to make it out. There's already a 4 out there, so now it's 8x times the cube root of, what's left? A 5xy squared. 5xy squared. Okay. One more. Fourth root, so we're looking for sets of 4. 2, 4, 8, 16, 32, 64. That's 2 to the 6th. X, 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 y, 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 y. 1, 2, 3, 4, 5. One more. Okay. Again, you could probably do that in your head. So we're looking for sets of 4. Set of 4. Nope. Set of 4. I kind of missed. It's a set of 4, and then since there's 8 of them, you should realize that there are 2 sets of 4. So 2y squared makes it out. We're still taking the fourth root of 2 times 2, which is 4, and we have x cubed trapped in there. So 4x cubed is trapped underneath the radical. That's all you can do. Okay? So that's exponents, and that's radicals. Now on the back, we're going to do some factoring. So let's factor. When you're factoring, you first want to always look for GCF. So these two are both multiples of 8, and then that will be 8x cubed minus 1. Now, you should remember that you're looking for either, if it's 2 terms, difference of squares or sum/difference of cubes. These are not perfect squares, but they are perfect cubes. So the rule is a squared, ab, b squared, and then you use SOAP for the signs. So the cube root of 8x cubed is 2x. The cube root of 1 is 1. A squared, 2x times 2x is 4x squared. AB, 2x times 1. 1 squared, 1. And we're using SOAP for the signs. So this is minus, same, opposite, always positive. The second one is also a sum of cubes. This is a difference of cubes, but also the same formula. So the cube root of 27x cubed is 3x. The cube root of 1 is 1. A squared, 3x times 3x is 9x squared. 3x times 1 is 3x, and 1 squared is 1. So when we do SOAP, same, opposite, always positive. The only difference between those, what you start with. You start with a minus or you start with a plus. Next one, you've got some quantities to factor out. So if I'm going to factor out quantities, I'm going to look to see first if there's a big GCF, and there is. There's a 3. And then how many x plus 1s can I bring out? So I have 2 here and 1 there. That means I can factor out 1. And then I can bring out 2 x squareds, or x minus 4s rather. X minus 4 squared, x minus 4 squared, so I'll factor those out. So what's left on the inside? 3 times 2 gives you 6. X plus 1 times x plus 1 gives you x plus 1 squared. And x minus 4 is fine. Minus 3 times 3 is 9. X plus 1 is fine. Oh, that's it, just minus 3. You need to simplify the inside, 2x plus 2 minus 3, and that will then make 2x minus 1. So the rest doesn't change, x plus 1, x minus 4 squared, times 2x minus 1. But you do need to simplify the inside. Let's try another one. Number 12. First, you should always look for a big GCF. These are all even, so I'm going to factor out a 2. That cuts everything in half. 9x cubed minus 27x squared minus x plus 3. Okay. Now there are 4 terms. So if there are 4 terms, we're going to factor by grouping. So the GCF between the first 2 terms is 9x squared, and that'll be x minus 3. Bring down the minus sign. Those don't have anything in common, so we'll say 1, and then that's x minus 3. Then my factors are 9x squared minus 1, x minus 3, and I'll bring down my 2. And you're like, oh, I did it, I'm great. Maybe. You do need to look. Are either of those factorable? This guy, those are both perfect squares. I'm subtracting. That's dots. This is 3x plus 1, 3x minus 1. I have an x minus 3 and a 2 still, but now it's completely factored. If you don't factor this, you are not completely factored, and the directions say factor completely. 13. Also 4 terms. No big GCF in this one, so I'll just do grouping. I'll find the GCF of the first 2, 8x cubed. And then I'll have 2x plus 1. Bring down the minus. Those 2 just have a 1 in common, and since it's negative, we're going to end up factoring out the negative. And now we have 2x plus 1 and 8x cubed minus 1. I know that 2x plus 1 is okay, but 8x cubed minus 1, we actually already did that. It's right there. So I can just kind of copy it and be like, well, 2x plus 1 is fine, but 8x cubed minus 1 is 2x minus 1, 4x squared plus 2x plus 1. That's the same thing we already factored. We're getting close. Number 14. These are the ones that mess with you. So if you see that there is a negative exponent, you are factoring that out. You are factoring this out. You don't have a choice. That's what you're going to deal with. You do need to look to see if there is a common factor in the front. So 10, 25, and 60, those are all multiples of 5. So I'm going to factor out the 5 and then the x to the negative 1/2. That is my GCF. So 5 times what gives you 10? 2. And then this is where you got to be careful. It's 3 halves minus negative 1/2, which is the same as 3 halves plus 1/2, which is 4 halves, which is 2. This is going to be x squared because you're using the exponent rules. 3 halves minus negative 1/2 is 2 whole. So we have 2x squared plus 5 times 5 gives you 25, and then it's x to the 1/2 minus negative 1/2 is 1/2 plus 1/2, so 1 whole, which I'm not going to write, minus 5 times 12 is 60, and I already took care of the negative 1/2. It's part of the GCF. We do need to see if we can keep going. So we got to find numbers that multiply to 2 times negative 12, which is negative 24, and add to 5. That would be, let's see, 2x squared. How about 8x minus 3x? That'll do it. Then the GCF would be 2x, x plus 4, minus 3, x plus 4. So my factors are 2x minus 3, x plus 4, and then your GCF was 5x to the negative 1/2. That's completely factored now. One more. Same game. We're going to first look at those 2. The GCF is 4. And then I don't have a choice. I'm factoring out the negative 1/2. Because it's a negative exponent, that's what's getting factored out. Now, let's see. What do we have left on the inside? Well, we factored the whole thing out. So we need a placeholder like 1 there, because something times 1 has to give you this. Plus 4 times 3 is 12. And then we have x plus 2 to the 1/2 minus negative 1/2 is 1 whole, which again, you don't really need to write. You get that. I'll simplify the inside. 1 plus 3x plus 6, which is 3x plus 7. That's my other factor, and I'll bring down these guys, x plus 2 to the negative 1/2. And that's it. So you have to simplify exponents, you have to simplify radicals, and you have to factor. And when you're factoring, there's a lot of different ways to factor. We've gone through all of them. You can go through your notes, you can go through my YouTube videos. But if you can do the practice quiz, you can do the actual quiz. So good luck, and have a good weekend.